In this video, I'm going to talk about anonymous delegates, and this is pretty much an advanced level concept. But as you'll see in this and the other anonymous delegate videos, as well as the generics videos, it can be a real time saver, and it creates very elegant code. Now in this video, there's really three concepts that I'm going to cover, but if you really only understand the first concept, that's fine. We're going to cover the others in depth as we use anonymous delegates more and more in our videos. So first of all, we're going to talk about the syntax of anonymous delegates. What exactly does an anonymous delegate look like, and how is it different than regular delegates? And secondly, we'll talk about the usage of anonymous delegates in those situations where you need to pass a delegate into a method that you might find in the .NET framework. And there's a bunch of examples of this in the .NET 2.0 framework, like the generic collection methods, or whenever you're using regex.replace method. It will require the use of a delegate, and this might be one way in which you can kind of use a shortcut to provide it what it needs without having to go through a lot of extra typing. And then the third concept is the concept of closure, which is a term that means your anonymous delegate understands the scope that it was created in, and it has access to variables that were passed in at the time it was instantiated, and it can use those values each time that instance of the delegate is invoked. So we'll build to that. Let's start simple and we'll build from there. To get things started, first of all, I'm going to do a brief recap of defining a delegate, and then creating an instance of a delegate, and then calling a regular delegate. So if you recall, you define a delegate like this. And we'll call it print message delegate, and we'll define it to require a string as an input parameter. So basically, we just defined a signature of a method. That's all we've done. Now let's create a method that matches that signature. So let's do this. Static void print message string name. And we'll just do something kind of cheesy here. Console write line. Hello. We'll put a replacement string in there. Okay. So now we've created a method that matches the signature, and now we'll want to create an instance of a delegate, of our delegate, and targeting our method called print message, which will be invoked whenever we invoke our delegate. So here we go. Print message delegate, and we'll just call our instance PM equals new print message delegate, and then we'll target our method name that we created just a moment ago, print message. So whenever we invoke PM, where will it point to? It'll point to our print message method. Okay. And now we'll invoke it simply by going PM and then passing in some name. Just do that. Now let's hit Control F5 on our keyboard to run this and see what we get. Hello world. Great. Okay, so it worked. And so this was pretty straightforward, just a basic review of how to define a delegate, how to point it at a method, like we did right here, and then how to call it, like we did right here. Okay. So now what I want to do is move on to what's new in the 2.0 framework, which is the anonymous delegates. In this particular instance of what we've done here is that the delegate print message has a name, or more specifically, the method that our delegate is targeting has a name. Now the delegate itself also has a name, which is PM, but when we're talking about anonymous delegates, we're really talking about the code that it's referring to, and in this case, it has a name called print message, which references this block of code right here. Now in C# 2.0, there's a way for this code, this print message code, to not have a name, And that might kind of seem weird, but just hang on. Hopefully it'll make a little bit more sense as we walk through an example. Right now, let's just tackle the basic syntax of how the heck we actually define one of these anonymous delegates. So rather than pointing at print message, let's just assign it to an anonymous delegate. So what we'll do is comment this out, go to the next line. Let's just copy what we had here, and so you can kind of see the progression of the changes that we're going to make. And so we're going to get rid of all of this, and instead we're going to put in here delegate string name. Basically what you do is you use the delegate keyword, kind of like you're writing a method, but you don't put any name in here, and you don't really specify a return value. It'll match that up depending on what's in the code body. Just make sure that the parameter list is the same as the signature of the delegate that you're assigning it to. So we have to make sure that our signature list matches our parameter list in the signature here as well. Okay. Now, after that, what we're going to do before we use our end of statement semicolon is add a little code block here. And so here we'll write console.writeLine hello whoops. There we go. Notice that we use the exact same implementation as we used earlier, but it's just declared in line rather than in another method. So let's go ahead and do this. Let's just comment this out so we no longer have the print message method any longer. And let's go ahead and run it, Control F5. And we still get hello world. So we get the same exact results. However, now we've used an anonymous delegate instead of a regular named delegate. So now it should be fairly straightforward to see that this code that exists right here in this new code block, it doesn't have a name. The only way that you can ever refer to it is through the delegate. Now in the previous case, it had that name print message, but in this case, it's directly in line. So the other way to think about this is similar to the string literal right here that we have as we invoke our delegate instance. We just directly declared a string instance there and passed it in as a parameter. We didn't put the string first into a variable. Now we certainly could have. We could have had a string assignment referred to that string literal through a variable like we're doing up here, where we're assigning a local variable to some value, but we chose not to do that. And that's exactly what we're doing here. The key here is that there isn't a method that we've defined. Now the compiler is going to take this block of code and put it somewhere and give it a name that it just makes up on its own, but we don't need to know what that is. And then it's going to create an instance of that delegate that refers to that hidden name and assign that into our delegate variable PM, and then we'll be able to invoke it using the delegate reference like we do right here. So, as you saw earlier, and I'll go ahead and run it again now, we get the exact same results, which is what we wanted. It just took slightly less code since we didn't have to give our method a name. But saving just a few keystrokes doesn't really get at the heart of the importance of anonymous delegates. And I want to talk to you about when you'll find yourself needing to use anonymous delegates. So in your day-to-day programming, you come across a method that requires you to input a delegate for a callback or an event. Now, in the past, to satisfy these methods, you'd have to create a delegate, which involves a lot of typing, and it requires the implementation of the delegate method to be in a separate place in code. But you might only need to perform some small evaluation, some small conditional expression that only returns a Boolean value or some small formatting expression or whatever. In this case, it would be nice to just put the implementation of that delegate right in line. And this is exactly where anonymous delegates come into play. You would use anonymous delegates when you need to pass a delegate into a method, but you don't want to declare a whole other method for it. You can just do it in line. So it's a lot more elegant. And let's take a look at a few examples in another project here. And I'm not going to give you this project just yet because we're going to use it as the basis for some of the more advanced discussions about anonymous delegates in the near future here. But in this particular example, we have a couple of places where we've used it. For example, let's take a look at this list sample and notice that here this find method calls for a predicate of type string, and we have defined that delegate starts with up here, so you can see we've created a delegate right there, and we implemented a very simple implementation here of an anonymous delegate, and we just return the name Bob. We do the same thing here. You can see in the find all method, it requires that you pass in a delegate for a method which will pass back a predicate that we'll use to match. So where do you get that? Well, you could again create a whole other method which basically implements your little starts with method right here, or we can just do it in line. Now this looks a little bit different than the case that we saw in what we did a moment ago. It's just a matter of putting things on separate lines, as opposed to here I just did it all in one line, which kind of is even more elegant, just one line of code. But you can see here we make sure that we have a delegate, and then we create the implementation of that right here. And it could be more than one line of code. In these simple cases, I've just shown one line. But in this case, we're just taking the starts with method of a string and passing in the letter D. But these are occasions in the .NET framework, particularly in the generic implementations of the collections, and you're often going to find yourself in need of a delegate there for predicates or for actions or things of that nature, which are essentially just methods that you'll need to create. And instead of creating a whole other method to do that, you can just inline it right here using an anonymous delegate. Let's take a look at the regex example. Here in this replace method, one of the things that you have to pass in is let's see if we can get IntelliSense here to help us out. There we go. So notice that there's this match evaluator. Well, what's that? We have to essentially pass it the address of a method that can do this evaluation so that the replace method works. And you can see here what we've simply done is declare a delegate and right in line created the delegate's implementation so that we didn't have to pop out to a whole different method. And so from a readability perspective, at first this might seem a little bit weird, but it makes a lot of sense to just be able to define this mini method right here in line and not have to go someplace else to see, oh, okay, it's just 2 lines of code. Okay. Another example here, and this might be a kind of a bad example because although it's, in this case, is innocuous, most of the time whenever you're creating, for example, a new thread and you have to pass in a delegate, typically that's going to represent a lot of work. And in this case, I only have 2 lines of code, but this might be an instance where you don't want to use an anonymous delegate. If, for example, you have 50 or 100 lines of code, you wouldn't want to just inline it right here. It might be more appropriate to go ahead and create a regular delegate and then just reference its name here in the constructor of the new thread. And so in these situations, if I'm coding in .NET 2.0, what I'm going to do is think, is this a method that I'm going to need in other parts of my code, or is this just a one-off? If it's fairly complex, for example, like we just talked about with the constructor for the new thread, uh, then it's probably not a good practice to put that code into an anonymous delegate block. You want to simplify it by keeping it in its own method. You would create a standard delegate instead of an anonymous one in that particular case. Or if you plan on reusing the method all over the place, then you definitely wouldn't want to use it within an anonymous delegate. You don't want to have to recreate that same code more than one time. It just doesn't make sense. But if the implementation of your little method is fairly simple, like we saw just a moment ago with the regex example, or even the list, or it's something like a conditional expression that returns a true or a false, or a formatting expression of some sort, then it's pretty much a one-use only method where you don't see yourself reusing that over and over and over. Well, then you can save yourself a lot of headache and a lot of typing by using anonymous delegates. I think they're easier to read. It's right there in the code. It's ready for you to read it. No need to scroll around and find the implementation somewhere else in your code. And finally, we want to talk about one of the more advanced features of anonymous delegates, and that is what you might hear in computer geek jargon called closures. And it's actually a pretty nice feature. It sounds complicated, but it's pretty useful. It's one of the reasons that you would actually want to use an anonymous delegate. So I'm going to do something that looks pretty strange at first. I'm going to create a method that will return instances of the print message delegate. So let's do this right above our static void main. We'll go static print message delegate get message printer string message. And I'm going to pass in a message sort of template, and in here I'm going to create an anonymous delegate. So what we'll do is return delegate, and here we're creating an anonymous delegate right in the method itself that will get passed back whenever you call this. So console.writeLine message name. Okay. And in this case, I'm going to use the message, sort of a template, if you will, that was passed in, and then merge that with the name that gets passed in to the print message delegate. So I know that seems really strange at first. We'll walk through this very slowly. Let's use it and see what it's actually doing. So now, rather than this here, let's go ahead and comment all of this out. And we'll just go ahead and start over. Something like this. Print message delegate PM equals get message printer hello okay. And then I basically call it the exact same way, just invoking it by calling PM, passing in world. So let's see what this does. If I did it correctly. Hello world. So you might be saying to yourself, well, that's not really that impressive. Let's do this, though. We'll just do PM Bob, PM David. Let's run it again. Okay, hello world, hello Bob, hello David, press any key to continue. So we can see how each time we invoked the print message delegate, how it got world, Bob, and David, but how did it retain this hello with the format string in there? Well, the key here is that unlike regular delegates, anonymous delegate can retain their original scope at the time that they were instantiated. So in other words, anonymous delegates understand the scope that they were originally created in. So when this delegate is instantiated, it's going to hold on to all variables, whatever variables you have. In this case, we have a message that's passed in upon the instantiation of our delegate. And those values, whether they're local variables, class variables, whatever you have sticking around at the point whenever you created the instance of that delegate, they're available each time you invoke the anonymous delegate. And that's basically the concept of closure. So you might be thinking, well, that's not really a big deal, but now I can create a whole other message. Let's do this: print message delegate. Let's just do this. PM equals get message printer, and we'll just do this: goodbye. Okay, and then so essentially we were able to change out the message. Here, let's run it real quick. Control F5. And you can see here at the very end we have goodbye world. So since we essentially created a new instance of our delegate, we are giving it a new set of variables that it can hold on to and use each time that delegate is invoked. I created a new instance, and now when I invoke, the scope of the anonymous delegate at the time when it was instantiated is available each time it's invoked. So now all this probably seems weird at first, but the thing to notice is that this value gets passed in as the message gets passed in. And when you do the return here in the body of this method, all we're doing is creating an instance of the delegate. So that whenever we actually invoke later on our delegate, it remembers from this call what the value is. And that is the part that's referred to as a closure. And to really demonstrate this, you probably should step through the code so that you can see the order that things are getting invoked in and that sort of thing. So what we'll do is put a breakpoint right here and then watch it do its thing. So let's go ahead and run this using debug. Okay, so you can see the first line of code. Let's just move this down. And so let's step into this. And notice whenever we step into it, it's calling the get message printer. We're calling our little function that's almost like a little factory that creates instances of this print message delegate. So let's keep on stepping here. So notice that when we step here that we're not going to go into that delegate code. We're simply going to return immediately. So the next time I step, notice that we're leaving. We're not going into the console.writeLine part. We're just going to leave our method. So at this point, all we've done is instantiated the delegate, but it will have captured this message value, which as you can see is hello with the substitution string in there. And now let's step into it one more time. And now when we invoke our delegate, now we're going to go into the actual implementation of the delegate, where we combine world with the hello replacement string. So now we're coming into the delegate code, and if we hover our mouse cursor over the message, you can see that it remembers what had been passed in at the time of instantiation. It remembers that it was the hello and the parameter 0 replacement string, and now has the value of name from us just calling it. So it's the same thing as when we call get message printer the second time. Let's go ahead and just go through this. Each time that we invoke it, it's going to continue to call this the delegate's implementation, passing in a new name, but keeping the message around. Okay. So now, whenever we create a new instance, you can see our message is now different. It's goodbye. And when we actually invoke it, then our delegate implementation is going to actually run then. and it's pretty much the same thing as it continues on through. So let's just continue to run it. Okay. Now this all might seem pretty odd at first when you're in the debugger and the cursor seems to be jumping around quite a bit. One point we're here, and then here, and then one point we're way up here, and then we jump back down to here, and then we go back up to here. But if you stare at it long enough, it ends up making sense in that this little block of code right here, whenever you see the keyword delegate, a signature and a block, it's really just creating an instance of a method, a delegate that points to a method, and you don't know the name of that method. So the key idea here is that the state of your anonymous delegate at the moment of instantiation is available during each invocation of the anonymous delegate. And as we work through some more advanced examples in the next few videos on anonymous delegates, we're going to look at this concept in more detail. The more you see it, the more you hear about it, the more you're going to realize that this feature is actually pretty valuable. So to recap, first of all, we reviewed the syntax of regular delegates, and then we showed the basic syntax of creating anonymous delegates. Then we talked about two primary uses of anonymous delegates. They can be used to keep your code tidy and elegant when creating delegates for use within the .NET 2.0 methods that require a delegate to be passed in. And then secondly, it can also be used as a form of closure to create essentially a factory of anonymous delegates whose scope can be set at instantiation and can then be utilized during invocation of your anonymous delegate. So like I promised, this is a pretty advanced concept, but it's important that if you only walk away with one thing, is to walk away understanding the basic syntax of how we created a anonymous delegate, and that essentially the concept of an anonymous delegate is that it is a delegate that doesn't have a name that we can just write the implementation of right in line as we're writing the rest of our code. The other things that we talked about, not super important that you get those completely under your belt at this point. They're going to become more obvious as we continue to walk through some of these concepts in the future videos. Thank you.